going to continue with that 5-1, that verifying those trig identities. And we're just going to kind of spice it up a little bit and then just kind of make our problems a little bit more complex. But the same process is going to apply. We're going to look at that left-hand side and try and change things into sines and cosines, and then see if we can manipulate that information to get it to where we want. Sound good? So let's try, I think I have like 4 examples maybe for us. We'll see how we get through these. So let's say we have cosine theta times secant theta, all divided by cotangent of theta. And I think we can manipulate all of that, and we can simplify it, and we can get it all the way down to tan theta. You guys think that's true? Yes. Right. We're going to try, right? So no different than the ones that we've been practicing. We're just going to look at that left-hand side for right now, and we're going to switch everything into
Cosines.
yeah, sines and cosines, right? Oops. So my cosine is going to stay cosine. Okay. What am I going to do with secant? One over cosine, right? And then since you have a fraction, if it makes you warm and fuzzy, make that guy a fraction too, if you want, right? All divided by cotangent. What do you want to do with cotangent? Cosine over sine, yeah. And now that we made it a real big mess, but we want to clean it up to try and get it to be just a tan theta, right? So let's start on our numerator. So on our numerator, what do we notice? Yeah, those cosine over cosine, they're going to cancel each other out and give us 1, right? And then we still have our denominator. So if you need to, you can rewrite it. So our numerator is now just going to be 1 all over cosine theta sine theta, right? And when we divide a fraction by a fraction, or if we just divide by a fraction, we multiply by the reciprocal, right? So you'd have 1 times sine theta over cosine theta, and hopefully that equals tan theta. And what's sine over cosine? Tangent. So tan theta equals tan theta. Bam! Yes, sir?
Well, couldn't we have just left the cotangent alone and then just made the numerator cancel out the numerator and make that 1, and then just be 1 over cotangent, and then it would be...
Yeah, yep, if you didn't want to switch them all at first. Yep, so from here, if you just had that, cosine theta over 1 times 1 over cosine theta, and you wanted to leave that as cotangent theta, yep, these guys cancel out. So now you have 1 over cotangent of theta. And even from there, if you wanted to, 1 over, what's the reciprocal of cotangent? Tangent. Yep. So yes, yep. If you can see those steps, then by all means, go ahead and take it. Yep. Usually we just go to the sines and cosines just to sit there. I mean, that's where you start off with trying to switch everything into sines and cosines, and then eventually, hopefully, you get to that point where you can see all those little guys. Yep. And even from here, if you didn't realize that that was the reciprocal, right? And I think this is what you were saying, and then switch this to 1 over cosine theta over sine theta, right?
I mean, I was talking about the reciprocal.
The reciprocal, were you? Yeah, exactly. So, yep. And that's where you, hopefully you can start to get to. Not too bad, right? A little bit more spice, but I think it's still doable. What do you guys think? All right. All right. let's throw some squares in there. What if we had secant squared? Ooh, let's put a t in there instead of an x or a theta. Over tangent of t. And I think that's going to equal secant of t, cosecant of t. If the t's are giving you heartache, right, or messing you up, switch them to x's, right? All right. Anybody got any thoughts or ideas?
Maybe like break the secant up.
Want to break that into two? Yeah, let's try that. So we got secant of t times secant of t over the tangent of t. Now what are we going to do?
And then sine and
Go to sine and cosine? Yep. What's secant? 1 over cosine times 1 over cosine all over sine t cosine t. Anybody got any ideas on what we could do now? Yeah, what was it? Yeah, multiply by the reciprocal, right? Get rid of those two fractions being divided, right? So we have 1 over cosine, okay, I almost said cost. Sorry. Over 1 over cosine of t. Now I'm just going to put a big old times there. Oops, I'm going to squeeze this up for you guys. All right. And then the reciprocal is going to be cosine of t over sine of t, right? What do we notice now? Yeah, those cosines, right? I can at least do it with one of them. 1 cosine over cosine, that's going to give me to 1. What do we see now? You want to clean it up? Oh yeah. 1 over cosine times 1 over sine. We're hopefully getting to secant of t and cosecant of t. What are we going to do now?
1 over cosine is secant.
Oh.
1 over sine is cosecant.
Yep. So did you guys get to where you needed to be? Yep. Look at that. You guys did that one all on your own. Pat yourself on the back. Good job, good job. All right. You ready for another fancy one? Sure. You gotta love these fractions. I know you guys are liking them, aren't you? All right. Whoops. So let's go with a 1 minus sine theta over cosine of theta. And I think that's gonna, I love those secants. I'm just like stuck on secants today. Minus tangent of theta. So usually our goal is to get that left side into sines and cosines. And we're already into sines and cosines, right? Then sometimes I look to see if I could do like a Pythagorean identity. Could I do a Pythagorean identity on that 1 minus sine theta? No, good job, good eye, good eye. It was a trick question, right? Why can't I use...
Not squared.
It's not squared. I'm so proud of you guys. Good job. Woo, woo. Extra credit for everybody, right? So I can't use my Pythagorean identity, right? So I'm kind of like dead in the water right now. So I'm like, what am I going to do? When I look on the right-hand side, I notice like they have an identity like minus another identity, right? So they kind of have like two little things going on. Well, right now with this fraction, I only have one thing going on. So somehow I got to split this baby into two. So you can take any fraction and you can split it, right? Because what's your common denominator? Cosine, right? So I can do 1 over cosine minus sine over cosine, right? So I'm going to split this into 1 over cosine minus sine theta over cosine theta. And hopefully that equals secant theta minus tan theta. And I think that's what I have now, isn't it?
Yep.
Secant theta minus tan theta. Right. Not too bad? All right. I'm going to give you the craziest one so far. And if we can get through this one, it'll be the last one. All right. So I'm going to go with sine of, you want any particular letter with that? You got any,
X.
you want to go with x? All right. See, you still love your x. In math, the x in math, the variable x, that x, right? You're so used to using x, you've used it since algebra 1, right? Plus cosine of x over cotangent of x equals, I think it's going to be sine x plus cosine x. Throw a whole bunch of them in there on you. All right. Anybody want to jump on this one and take the lead?
Change the tan to the sine over cosine.
Over sine x over cosine of x.
Yeah.
And sometimes when I do these, like that, the fraction bar that like separates that numerator and denominator when we do this, sometimes like make this one a little bit longer or like a little bit thicker. Because like right now how we write it, like if you make it where the bars are all the same length, it's like, is it sine over sine all divided by cosine of x? You know what I mean? Or is it the sine of x all divided by the sine over the cosine? So whatever is that original fraction bar, I usually just either make a little bit longer or a little bit thicker, just to kind of keep everything so we don't, right? All right, we gonna keep going?
Yeah.
All right, so what do we want to do with that second piece? Kind of the same thing?
Take cotangent and do the cosine over sine.
Cosine over sine? Yep. And hopefully we can get it into a nice little easy sine x plus cosine x, right? All right. So we got two options here, right? What's our two options right now? But what are we doing? We're adding, right?
Oh, just kidding.
No, you're fine, yeah.
I did the reciprocal.
Yep, you can, yep, yeah. So you can either like try and combine all of these into one fraction, right? Because you now have a common denominator. Or we can try and simplify these fractions a little bit by multiplying by the reciprocal, right? So think somebody said they wanted to multiply by the reciprocal. And that would be my guess too, because I think that kind of cleans it up a little bit before you sit there and deal with that fraction, right? So I'm going to multiply by the reciprocal. So I'm going to have sine x. And like I said, if you want, make that a fraction. This is going to be sine x over 1, right? Times the reciprocal, cosine of x over sine of x, right? Yep, yep. And then if we continue with the one on the right, same concept. We can do that over 1 times the reciprocal of sine over x over cosine of x. Sine over sine is 1. Cosine over cosine is 1. Oops, I forgot to write my right side. How many of you guys forget to write the right side when you're doing these? So out of this guy, what am I left with? Cosine. Here I'm left with sine x equals sine x plus cosine x. Are those babies equal? Yeah, yep, yep. So if you want to be fancy, you can rewrite it to match up perfectly, but you don't have to. Right. How'd you do yours, Taylor?
I write mine differently. I don't do like sine x over the big one. I write sine x and then I literally put the divided by sine over cosine and then I'll do it with my head because that messes me up. I don't know why.
Why? No, that's fine, absolutely. Yep. So
I just skipped that whole like step that you did and I just dropped it down.
Yep.
to
So you get sine of x divided by sine of x over cosine of x, right?
That's how I write it, and then
Yep.
I can see that they cancel easier.
Right. Yep. Nope. Absolutely. Right. And then if you were to do the reciprocal, right? If you wanted to, right? Over 1 if you wanted to, or however. Yep. Absolutely. Absolutely. You don't have to do the division bar. You can do the division symbol.